Rajant Corporation is the developer of the InstaMesh technology and the manufacturer of the Breadcrumb wireless network for military and industry. The company has introduced a long-range backbone system that takes advantage of the unique capabilities of InstaMesh and breadcrumbs to provide a zero-configuration, low-cost broadband communication system that will cover a large geographical area.
We're out here in Arizona to test for the first time a new Rajant antenna called the Raptor antenna. It's a long-range antenna combining 3 breadcrumbs in order to allow Rajant's breadcrumb network to expand over large areas.
The Raptor system combines 3 of our LX4s and sector antennas. Each unit has to be connected to 3 of the antennas. So here we have our first row. This antenna is a dual band 2.4 GHz, 5.8 GHz antenna. And this is our 900 MHz antenna. And this connects to our first unit. Then the second row connects to our second unit, and the third row will connect to the third unit. Each row is shifted by 120 degrees so that we can have a full 360 degree omnidirectional pattern. The sector antennas can be 60 degrees, that means 6 units, so it can scale.
The purpose of this antenna is to take Rajant technology, Rajant breadcrumb technology, and deploy it over vast areas.
The LX4 units in the Raptor setup connect to each other through Ethernet using Rajant's APT protocol. APT uses the 100 megabits per second Ethernet connection, and that allows the packets to be transferred between the LX4 units in real time very quickly, and so that they can travel towards their final radio destination on any of the antennas in the antenna array. Rajant's APT protocol can handle loop conditions, can eliminate loops, so plugging in units in the same switch is safe, will not create a loop condition. A Raptor system can also be a gateway. One of the LX4s in this system could be plugged in to an external network, and that unit will provide the gateway for the whole Raptor setup. Today we performed long-range performance testing of our Raptor system. We had an LX4 unit with omnidirectional antennas installed in a helicopter. We had 2 of the antennas, the 2.4 and 5.8 sticking out of the left side of the helicopter, and 1 antenna, the 900 MHz antenna, sticking outside of the right side of the helicopter. We are going to measure throughput at different distance points, and also we are going to keep track of the SNRs. Okay, we have 33 dB SNR on 900 and about 20 dB SNR on 2.4 at 3.03 miles. I'm starting some hyperfrans, 8 megabits per second, 9 megabits per second. Okay, we got all the data. So next, okay, slow down, stop here. Okay, we are at 30 miles, 29.92 exactly. The pings are good, 32 millisecond, 50 millisecond, 45 millisecond. We were actually able to keep connections and pings going on up to 30 miles. We had a great throughput, tens of megabits per second, more than 20 megabits per second, and up to 3 miles. After 3 miles, the throughput started slowing down a little bit. At 5 miles, we were still close to 10 megabits per second, but still at 10 miles, we had up to 5 megabits per second of performance, but no packet losses. Very reliable communications with no packet losses. And as we neared 30 miles, we still kept reliable communications. The 900 MHz radio, due to its propagation characteristics, seemed to do better at long range. 2.4 GHz also held up pretty well up to 20 miles. The 900 MHz radio actually was around 10 dB, even around 30 miles range, which is quite impressive at that distance. So overall, that was a very good result and experiment for us. We kind of did a quick and dirty test where we did not optimize the cable lengths, and due to the wind speed in the helicopter, the antennas got misaligned by as much as 30 degrees. But even without much effort and as a quick test, we were able to accomplish this. We are going to use a vehicle-mounted trailer. and we are going to separate in distance from the Raptor system. Difference of this test compared to the helicopter test is that in the helicopter we had omnidirectional antennas. Right now we have set up also directional sector antennas on our trailer, and this is representation of an infrastructure to infrastructure link, which would be common in big installations such as mines, where you would have several infrastructure points serving their radius, and then also many more client devices such as trucks, which have the omnidirectional antennas. So we would like to get a feel of the connection that we would normally see between two Raptor systems in that kind of environment. We are now at 1.7 miles distance from the Raptor system, and we have excellent signal strength, low 40s, a couple high 30s, and we have 20 megabits per second. The trailer is 5.7 miles away from the Raptor system right now. We are seeing signal strength in mid 30s, about 34-35 dB, and also some high 20s. We have 2, 4, 6, 7 connections total right now to our Raptor system.
The technology we tested here successfully is going to allow us to connect critical infrastructure into large-scale mesh networks, providing all kinds of different features relating to data, video surveillance, sensor packages, just traditional data applications. All will be possible in very remote areas. So that's what we set out to test, and we tested it successfully. It's our goal to be able to link all those platforms in the Gulf of Mexico in one big network that we call Gulf Mesh. It was designed by our development team, tested here out in Arizona, and worked very well.
For more information, visit www.rajant.com.